All right, we'll finish up chapter 15. We'll go into, oh, I said it right there. Chapter 17 after that. And that's pretty much all we got left for this evening as far as plans for everything. But get through this, shouldn't take too long. All right. So, heat pumps, as far as the sequence of operations concerned, for how they're going to operate, you're going to learn more about that in depth, like I said, in your heat pump class for that order of operations. When you hear about these orders of operations or orders of steps or anything like that, depending on the type of system, it's going to be different, obviously, but this is what's going to allow you to do your troubleshooting the easiest way possible. By learning what comes on in what order, you can basically figure out where along the steps did it stop turning on, where along the step did it stop functioning. So that's what we're looking at for our different types of sequences of operations and everything like that. Now, with a heat pump, you can have where you're going to have some unique things that you'll see on certain systems, and we'll talk about it a little bit more in a minute. But one of the things you're going to see is, we had those different abbreviations, but one of them you'll see is probably Y1, Y2, and W1, W2. All right. So Y1 is your first stage cooling. Y2 is your second stage cooling. You can guess that W1, your first stage heat, and W2 is our second stage heat. Now, most residential systems will not have two stages of cooling. They will not have Y1 and Y2. What they will have is W1 and W2. And they'll have that especially for heat pumps because you're going to have W1, your first stage of heating, is that heat pump coming on. Remember I said once it gets colder and colder outside, it's going to turn into ice outside. But when it turns into ice outside, when it freezes over and has to go into a defrost mode, we still need to have heat produced in the building somehow. So we have an emergency backup heat. That's our second stage heat. That can be either your electric heat strips being the most common one, or you can have it where it's a gas furnace. Just depends on what kind of setup the person's got in their home. But typically, you'll have your first stage heat would be your heat pump. Your second stage heat would be your electric heat strips. So we got a lot of different things that can operate and work off these. But the order of operations, how they're going to work and everything like that, y'all learn a lot more about that as you continue through. All right. Total system control modules, as far as modern advanced residential air conditioning systems go, this is where we're talking about these more complicated systems where it's no longer just a 24-volt signal being sent back and forth. Also, information is being shared between the outdoor unit, the indoor unit, and the thermostat. Those three are linking up back and forth to each other. And they're going to feed each other information through microprocessors, through control boards, basically computer signals almost is what it's like, or it's what it is. And these will help maintain more control over the living space's air quality, the temperature, the humidity. All of these will play more of a factor, and it will be able to react to that faster. It'll be able to react to a hotter day faster because it realizes Well, if I'm hooked up to the Wi-Fi and I see the 7-day forecast, then I know that the next 2 days are going to be, mid 90s, and the day after that's going to be 100. The system can go ahead and be ready to start running at that really high speed, and having to do huge amounts of cooling. So it just depends as far as what kind of system we're dealing with, what brand it is, how that kind of stuff's going to be wired up, and everything. But depending on what kind of add-ons you have in the system, you can do all sorts of stuff with it. One of them is going to be zone controls. So zone controls are getting popular residentially. They're not commonplace, I would say. I'm not going to say every house has got a zone control system, or every house after a certain year has a zone control system, because it's not true. You can't say every. But you're seeing them put into more and more homes because they're becoming cheaper, is one of the big things. And they help with efficiency a lot, especially with a larger building or a larger home, when you're dealing with, not a 2-bedroom, 1-bath, but, a 6-bedroom, 3-bath, something like that, where you're dealing with, this is a family, this is a house meant for like a family of 6 to 8, easily. Well, with those larger homes, you've got issues where, and even in smaller homes, you can have issues of hot rooms and cold rooms, and uneven heating and cooling. Don't go to that bathroom in the middle of the winter, you're going to freeze your butt off. Don't go to that, bedroom in the middle of summer, you're just going to sweat, unless you're wearing gym shorts and, nothing else, basically. So that's what it comes down to. But a zone control system, what it does is you have it where each room or each zone is going to have a different temperature sensor, different thermostat, basically. It's going to feed that temperature information back to a zone control board, back to one of these big boards like this. I've seen them before where it's literally just rows, and I'm talking residentially, just about 50 connections on each side, for it can take in as many zones as it needs to. Just depends on how much have you got money-wise and how much are you willing to invest in. So with the zone control systems, you have it where each room is going to have its temperature sensor. Each room, the ductwork connecting to that room, it will also have an actuator and a damper that will open and close the ductwork, basically. Close it off from letting air flow in, and open it up to let air flow in. This is what makes zone control so great, is you can have it where as each room needs heating or cooling, it'll call for it, it'll go to that room, get it to that temperature, and then it'll shut it off. Say, yep, stop the airflow, we're good, don't need any more, finish up cooling the rest of the house, until basically, it kind of, each room or each call would open one by one, and then it's going to close one by one. So zone control systems are pretty cool, but they're interesting. It just depends on manufacturers, how far as how they're going to be wired up and set up and everything. But it will have it where it's going to be a temperature sensor of some sort. It could be a thermostat, it could be a thermistor, some sort of damper with an actuator, and then an actual control system. Zone control systems will typically be independent of a residential systems air conditioning control board. It's not going to be like Carrier made the air conditioner and it comes with a zone control board inside of it. No, zone controls are always pretty much secondary options. They're add-ons. They're going to be made by control companies like Siemens and Honeywell, stuff like that. So, all right, mini split control systems, very, very, very simple. All right, a mini split is going to be running off of all 24 volts. The wiring is very basic because it's not taking up a lot of space. The big thing with a mini split is that you will have a system that does not have a thermostat on the wall. Instead, it will have a control remote. That's usually what it'll do. It'll have a remote control, and that will actually be what turns on your heating, your cooling, whatever mode it's going into. These, again, mini splits, these are those tiny units you've probably seen at restaurants or small businesses and stuff like that, where they convert an old building to a storefront or something really quickly. they'll put a mini split unit in where it doesn't have to have any ductwork. It just needs a box sitting on the wall inside, and then a big, a small box unit outside, a small little condenser. So the zone controls are pretty simple. They've got, you've got multiple styles of them. You can have them where they can be single zone, multi-zone. And the nice thing is they require no ductwork, 0. So mini splits are becoming popular. Again, that's another one. I was talking about earlier, packaged units are really popular for older homes in Richmond because you can't fit ductwork into the walls, because the house was never meant to have ductwork. Mini splits are another popular option because you don't have to worry about ductwork. You don't have to think about it at all. And that's really good for residences that never had ductwork designed for them or anything like that, and commercial businesses where a storefront might have never meant to be a storefront. It might have been originally, it was just a storage room or something like that, and they want to convert it to, we need more seating area for our customers. Well, we need that room to be conditioned, otherwise you're going to have, more room for customers, but they're going to be more pissed off because they're sweating or they're freezing or whatever. So mini split systems, again, they're going to be pretty simple. All right, so we got 2 different types of wiring you're going to see on a wiring diagram. Always, you're going to have what's called factory wired, which is everything that comes pre-connected from the factory, and then you'll have field wiring. And field wiring is very simple. You're only going to have 2 things you have to field wire on pretty much any residential system. One is your high voltage. So you're going to field wire in your high voltage 240 to your outdoor unit, your 120 to your indoor unit, whatever the voltage is supposed to be, you're going to connect your high voltage. And then you're going to connect your low voltage, and that's it. Your low voltage is going to be from your thermostat to a control board typically, or to different components. Control boards are really, they make things a lot easier. But yeah, that's all you got to field wire. As far as field wiring is concerned, your high voltage connections, your low voltage connections, done. As far as all the connections between, pressure switch and temperature switch, and from your contactor to your compressor and all that kind of stuff, that's all going to be done at the factory. That's all factory wired. So field wiring, the one big thing is, especially for control systems, making sure you get the right sized wire, and making sure that you've got the proper colors and everything lined up. Makes life so much easier. So for this one, we got fan, 24 volts power, we got heat, cool, and common. As far as our order for these wires right here, because we've got a fan, it's going to be our green wire right there, 24 volts. It's going to be our red. Heating is going to be our white. Cool is our yellow. Common is our blue. And those are just, that's what you're going to see. You'll see these 5 connections going into a thermostat. You'll see those 5 connection terminals on your control board at the indoor unit or at the air handler. And you'll see it at those connections at your outdoor unit as well, at least for the cooling and the common, at least. The thing to watch out for with these, honestly, is just making sure that the color stays consistent. I went to a call and I could not for the life of me figure out what the hell was wrong with the system. And what had happened was some smart person, I could use some mean words, but I'll call him a smart person, decided to change the wire color from the indoor unit to the outdoor unit for the call for cooling. And I didn't think that they would change the color, so I was assuming, it's going to be, this is the right color and this is the right thing I should be looking for. And for some reason, I'm not getting it. I don't know what's going on. Never trust 100% that these colors are correct and that these connections are done properly. Always verify for yourself and make sure everything's done how it should be. So system startup, is typically going to be, you know, right when you finish installing a unit, and you've got it where it's first starting up, that's what you're going to be doing, as well as any time that you do a repair, replace a component or a part, or anything like that, you're going to be doing a system startup check to make sure that the system is working properly. Whether it's your blower motor you're checking, just like we were in those simulations. Last thing we did, close everything up, turn everything back on, sweep up behind ourselves, make sure everything's doing what it should. I've been on calls where I can tell that someone never fully ensured that the system was working before they left. I've been on calls for complete installs where that's happened, where I know for a fact, because of how it was wired, that they never got the outdoor unit to run. It was never actually running ever, so I don't know what they were thinking. And then I had it where it's calls where, you know, it could be an appliance that they thought was working and it isn't, you know, a humidifier. Oh, I got the humidifier wired in, it's good to go, let's get it done, you know. And then the system just never worked because they never wired it in properly, you know. And techs will be able to tell when they come behind you, you know, is this an actual issue where they installed something and shortly afterwards it just happened to go, or did they really just not ever get it right from the get-go? That's one of the things with the when you're going on these calls and making sure that everything's working properly. If it's not working, it's not going to work, you know, with you just walking away magically. So Unit 15 talks about it. Chapter 9 talks about it as well. Customer relations and the importance of what are called soft skills. Understanding how to relate to people, how to talk to people, how to respect people in their homes and everything like that. It's pretty important. The big thing I have to drive home always is that y'all, I mean, it's never going to be because you're a great technician that you get a job. It's never going to be because you know so much about HVAC that you're going to get a job and you're going to get calls and you're going to go out and you're going to do work. The thing that keeps you working, the thing that keeps you going, the thing that allows you to have a career and opportunity is a customer. Whether that customer is a business owner, whether that customer is a homeowner, whether that customer is an industrial plant operator, or just Joe Schmo trying to figure out what's going on with his HVAC system, or his refrigerator, or whatever it might be. Could be, you know, a restaurant owner. Could be a guy who owns a couple of franchises of Burger Kings or something. So it just depends on that kind of stuff. But customers are the reason why we're always going to have a job. That's what it always comes down to. So you have to treat your customer right. You have to take care of them. Now, some of y'all already know this. Some of y'all are good with customers. You understand, you respect it. It's not a matter of, oh, the customer's always right. It's a matter of the customer is always important. The customer is the reason you're there. It's, you know, as much as I love taking care of people's HVAC units, the HVAC unit's not going to call me and trust me to go take care of that system for them. The homeowner is, you know, they're the one that's going to trust and call and make sure, hey, let's get, you know, Marshall out there. Let's get him working on my system because I want him to be the person out there working on it. So it's really important to be really respectful and to carry yourself professionally when you go to a customer. Maybe an acronym, that is a very good one. Listen, ask, simple, teach. Okay. LAST, L-A-S-T. Listen, ask, simple, teach. These 4 things will help you out so much when it comes to customers. It helps. It's not a perfect system, but it helps keep you focused on, okay, what's important between me and my relationship between me and this customer. So listening, first thing, that's what you have to do. If you're not a good listener, work on it. Work on it. You have to be a good listener as an HVAC technician. All right. You're going to be there for maybe 30 minutes to an hour to try and figure out a system. That person's living with that HVAC system the whole time. Ask them questions. Listen to what their problem is, though, first. Is no heating? Is it no cooling? That's the basics. Listen to how long has it been out. Listen to see if they say anything about, you know, what's important to them. Why is the reason that they want you out there at a midnight call as opposed to can't you wait until the morning? And if you listen to the concerns of the customer, you're going to understand and empathize and feel more for where they're at, which is what you should do, because you want to understand, okay, what's important to this customer? Let me get this done for them. And if I can empathize with them and help, and if that helps me in my relationship with them and their relationship with the system and maintaining it, then it's worth it. The second thing you want to do after you've listened to your customer and all their complaints and everything like that concerning the HVAC system, ask important questions. Ask, how long has the system not been operating? Has anyone looked at this recently? When was the last time you had a tech out here? Had you noticed anything strange prior to the system not operating? You know, was it starting to slow down? Was it starting to speed up? Was it sounding different? You know, all these kinds of things are questions that you've got to ask your customer. So you listen to them, ask them important questions, and then you keep it simple. Simple skills are things like, you know, checking your voltages, checking your basic components and everything like that, but keeping it simple with your customer. Don't go into detail about how transformers work and high and low voltage and all. Try to keep it relatable. Make it so it's something that they can understand and connect with on a general level. Think about whatever helped you click and understand a concept finally for a system or for a component. Try and explain to a customer. Try to explain it to them that way, because they're coming into an HVAC system and into this the same way most everybody does when they come to the school here, where they've got no experience, no understanding of it. I heard a term or two and I heard that it's a career. You know, for them, I've heard a term or two. I've had a guy come out here once or twice, you know. Simple, all right? Keep it simple with a customer. Make sure that they understand what the issues are. Make sure they understand the difference between a repair and a recommendation, all that kind of stuff. Last thing you got to tell them is teaching your customer. And this is where you talk to them more about your responsibility as an owner of this equipment. You must do these certain things. Here's what I would like to see happen. You know, the other thing is you can teach them. You can teach them about, you know, just how an HVAC system works. It's not going to cool anything down. It's just taking heat from somewhere where you don't want it and throwing it somewhere where you don't care about it. You know, and that's stuff that you'll talk to your customers and be able to make that connection. So listen to them always, ask important questions, keep it simple, and teach them about their system. I can't tell you, this is the weirdest thing. I would never have thought this was the reason why I got so many callbacks, and not bad callbacks, callbacks for people who were like, oh, that's the one technician I want at my house. I just want that guy. That's it. One of the biggest things that got me that relationship was a teaching moment. A lot of people have in their homes, without even knowing about it, they've got a scheduling thermostat. That scheduling thermostat has some energy saving options on it that make it so that you can save a lot of money in a month just by adjusting your thermostat up and down according to when you're at home, when you're asleep, when you're leaving for work, all that kind of stuff. When you walk a customer through that and then you show them how to set it up and you help them set it up, I mean, they are going to be like, oh, wow, that's really nice. Thank you so much. You know, and I had it one time, I'll never forget, there was a lady and was leaving her apartment complex or her apartment. I got down 2 stories of stairs, walked maybe 20 feet to my truck. I got a phone call from the main office. I'm like, oh crap, what did I do? You know, because that's my reaction always. Even if I'm not doing anything, what I do. It was the main dispatch leader, and she was like, hey, I don't know what you just did over at the lady's house, but she was ecstatic and wants you back out there every time and is going to recommend, you know, you to be basically the tech for everyone in that area that she knows. And I'm like, oh crap, like what did I do? But I thought about, well, I walked her through her scheduling thermostat. That was it. Scheduled the thermostat for her, walked her through how to do it. But because, she's a little bit older, she just didn't have the time for it. It's just that nice little quick extra thing that I didn't charge her for. It didn't cost me anything really, except for a little bit of time. But what it really built up was that relationship between me and that customer. If it wasn't for the traffic in Northern Virginia for moving me down to Richmond, I'd probably be still going out to her house on a pretty regular basis. And you'll get that. You'll get customer after customer. And you treat them right like that, and you really take care of them, and you really are concerned for their well-being and their system's well-being. Because, if the system's not doing good, guess what happens to them? They're not going to be doing good because they're going to be having to pay money. And I know anybody who gets a couple $1,000 bill, all of a sudden, however happy you were before, you're all of a sudden you're a couple $1,000 less happy. Always try to tell the customer and understand that's why you're trying to help them out. All right, cool. So we go check 15. Oh, come on. We'll go right into 17. And then we'll be done for the evening. So this is, and the reason why we can go through this pretty quickly is because, like I said before, you're going to learn more about the residential and even commercial and industrial heating controls and circuits and everything like that when you get into those specific classes. We're going to go over the bare basics and minimums and everything like that for it. So for a commercial or industrial application, most of the time, you've got it where you're going to be using refrigerant less and less with these systems. You're going to move hot and cold water to heat and cool a space is what eventually becomes a more common, simpler, and cheaper option. As far as who's going to choose the equipment, it's going to be from architects and mechanical engineers and designers like that. So we got a lot of different things with that. Again, large industrial condensing units, industrial package units. Typically, you're going to see most commercial and industrial is going to be a package unit of some sort. You can come across it where you'll have an extremely large, split unit basically. But instead of being, an air handler located all the way inside on that floor that it goes to or something like that, it'll have the refrigerant run a shorter distance, quicker cycle, and allow for that cooling and heating process to take place a little bit sooner than we expect. So that's the nice thing about the package units. The split units not used as much, but you will see them from time to time. For industrial package units, you'll see it where it's either everything's all together in one place, or there's a short run between the compressor and the condenser, or something like that. So right here, this picture it's got is showing a blower fan wheel, all right, and it's connected. It looks like it's belt driven almost, as far as the motor is concerned. So that's pretty typical for industrial, especially, and for commercial units to have it where the fan motor is not going to be driven directly on the shaft of it to move that airflow. It's going to be connected by a belt and some pulleys. Good Lord. So other things you'll have for industrial heating and cooling, besides our refrigerant flow, besides our airflow, with that, We're also going to have airflow going across hot water coils and cold water coils. The hot water is going to come from boilers. The cold water is going to come from chillers. And y'all learn more about boilers and chillers as you continue through, like I said. The big difference with commercial systems and the circuitry for them is the voltage, all right? So typically residential, we got high voltage comes into a transformer, changes to low voltage, and we use that low voltage for our controls. Industrial commercial, there is no transformer. You use 120 as your controls. So a contactor, instead of having 24 volts going to the coil, it's 120 volts going to the coil. Now the reason they do that is because when you're dealing with larger equipment, you're dealing with higher voltages, and the last thing you want to have shut down a commercial or industrial system is a $180, $250 transformer. Like that's just, no, that's not worth it for me to lose potentially thousands of dollars of revenue as a business owner or as a homeowner. Losing money from where my brain just go? Losing money basically because it's consuming more power than it needs to, all that kind of stuff. It just doesn't, it's not worth it. So with this, we have it where the commercial doesn't have to worry about that transformer blowing. It's the same thing with commercial systems. You're not going to see capacitors used as well. Capacitors and transformers, not really going to be on your high voltage commercial industrial systems. But that gets more into the fact that we're dealing with three-phase motors. We're dealing with stuff like that that can be a little bit more versatile, I guess would be the thing I'm looking for as far as words are concerned. So again, components, same exact ones we're going to see for any kind of residential system. We still got a compressor, a blower motor, a condenser, fan motor as far as the circuits are concerned. Only things that it's putting here that are completely optional is water chiller control circuitry and water cooled condenser interlocks or controls. The whole idea with water cooling a system or a substance is that water where it's sourced and everything like that will be a more consistent temperature than the outdoor air would be. And the more consistent temperature that we have for our heat exchanging, for our heat transfer and everything like that, the less energy it'll actually consume, the faster the cooling or heating cycle will be completed, and it helps the systems out run really, really well. So again, compressor, condenser, those are your two, and then your blower motor as far as your safeties and controls are concerned. Again, like I said, ground level or rooftops where you're going to be seeing your typical package unit. That's where they're pretty much all located. They can be multi-zoned. Some of them just depends. Like I said, you can have it where it'll be zone controls in the dampers, or you'll have it where you've got 7 or 8 package units on the roof, and they'll all be linked up to each other, and they can actually communicate saying, okay, this side of the building's getting cooler, this side's getting hotter. And they'll all feed into one main control board or thermostat system eventually as well. So air-cooled, this is your typical thing for residences or for more of your comfort cooling. You'll see it where it's going to be air-cooled package unit. That's what I was talking about before. It's just, basically the same thing as your residential unit, just everything's all together. Big advantage with the air-cooled is that everything is going to be, you can have it where you can have components mounted inside, outside, without having to, sorry, brains having a minute to catch up. All right. You've got it where the big advantage with this is the fact that you can have your different areas for heat transfer mounted separately and away from each other, and it makes life a little bit easier. And that's if you've got that remote condenser where, and this air-cooled package unit with a remote condenser is pretty much a split system at that point. That's literally what it looks like. Water-cooled package units, again, they're usually built in one unit. It'll have a cooling tower, it'll have a pump, it'll have some extra components. Y'all will learn all about these when you get to your commercial industrial class for package units and everything. Types of commercial and industrial control systems, big thing we're going to see a lot of times is we can get really complex control systems where the controls can take up an entire room or an entire wall. You can have it where it can be very, very high tech, where you can literally hook up a computer to it to start working on it. It just depends on what level you're dealing with. How large of a system is it? Just one Wawa, or is it a 16-story building? You know, that makes the big difference. So, basic controls you're going to see. Electronic is somewhat used for our industrial and commercial, but pneumatic is very popular as well, where it uses air pressure to send signals to turn systems on and off and everything. Again, pneumatic controls you learn more about in basically in your 115 and your 120 classes. They talk about it a lot. What it uses, instead of an electronic signal, it uses air pressure to send a signal to turn on and off thermostats, fan motors, everything like that. To operate relays, it's all going to be off air pressure. Again, more things that are nice. That's another pneumatic control. Nice thing about it, explosion proof, easy to set up, and very, very low cost as far as maintenance and running it and everything. Electronic controls, or DDCs, direct digital controls, these are your ones I was talking about where it's going to take up like an entire room sometimes, depending on how sophisticated it is. These are the ones where also you can hook up a laptop, depending on how sophisticated it is. You know, if it's a DDC control system from the early 2000s versus 2020, it's iffy whether or not you're going to be able to hook up a laptop to it. Nowadays, pretty much always, yeah, you can hook up some sort of computer and everything with it. And with that computer, it's going to be reading off the information from this microprocessor, the actual computer part of everything. All right, cool. That's all I got for tonight. Again, guys, I will see y'all on Wednesday. I'm going to send out some information in regards to lab work, the videos and everything like that within probably sometime tomorrow morning. I'll have everything ready for y'all. And that way you can be good to go. And then going to try and get everything organized as well for y'all to get online for that simulation. And that way you can have access to that and we can work on those together and everything. All righty, gents. I will see y'all on Wednesday.